So my motivation as a startup founder would be agility, like I said, right? Can I move fast? Are my teams independent enough? That'll be one important advantage. Then safety and availability of my application is another one, right? Like that you're able to reduce the blast radius of your code. Build test cases that are very specific to each microservice and not have unpredictable code paths. But there is also the advantage, if you're going serverless as much as possible, there's an advantage of cost over there as well, like you were alluding to.
Thanks, Ali, for joining us. So today we'll talk about building modern applications using serverless and microservice architecture. So what is a microservice architecture and what are its benefits?
A microservice architecture is where you break your big application into smaller pieces, as small as possible, with each piece delivering a very specific value. And then each of those pieces or components then interact with each other through APIs. So that is, from an architecture perspective, that's what's different. That instead of a monolithic application where everything is connected to the same code base, you sort of tease apart the code base into smaller functional units as to what each microservice should be doing, and then you have them interact with each other through well-defined interfaces.
Mm-hmm. In terms of talking about benefits, in terms of performance and scalability.
More than performance scalability, the biggest benefit of microservice architecture is agility. So the problem with monolithic applications is that they become really big and everybody's contributing to the same code base. And it becomes very hard to manage those changes as they're coming in because there's so many different teams. And you might be making a change in a very different component, but it gets queued behind all of those changes by other teams in absolutely different components, but it's going through the same testing cycle, the same deployment cycle. So you're not able to move fast enough if you don't have a microservices architecture. What a microservice architecture allows you to do it, when you break it down into these smaller microservices or components, each team becomes independent. Now each of those teams can actually run sprints of their own. They can test their code separately, and they can also deploy it in production by themselves. That has, just as a byproduct of having that independence, you also get better safety because each microservice now tests itself code, smaller code bases, and a smaller blast radius as well. You do get other benefits like you have well-defined interfaces that these services are using to communicate with each other, which means that the code paths that you exercise at the back end are also more well-defined because you only expose a certain set of APIs and you can only communicate with another microservice through those APIs. So the code paths are not as unpredictable as they could be in a monolithic application. So it's just easier to test those things as well. You have fewer lines of code to test. You have smaller test corpuses as well. So it just helps you sort of get more out of the same team by just dividing it up into smaller components. You do get some, I wouldn't say you get a lot of performance benefits. You probably get more performance from a monolithic application if you really architected it well. But in the long run, it's just very hard. It becomes more and more fragile over time. It becomes more and more bulkier over time, harder to maintain, harder to operate, and it becomes more and more difficult for teams to contribute to the same code base. And that's where the agility and safety benefits of these applications trump some of the performance hits that you might be taking because you're moving to more performance to a microservices architecture.
Okay, so when it comes to architectures, there are concepts like monolithic, service-oriented applications, and microservice architecture. So what are the differences? Maybe you can go into each.
Sure. Monolith is one big code base. Everything is connected through functions that are part of the same code base. So whether you're calling a database, it's part of the same code base. If you then go to an API layer, part of the same code base, generally maintained as part of one repository of code as well, which gets packaged as, monoliths, you could package them in different packages as well, but generally they even get packaged as one big container or one big VM that gets deployed somewhere. That you can see just by the nature of a large code base becomes more fragile over time. Just by the nature of a large code base becomes harder to test. And by the nature of that, it just slows teams down because it's just too much code and you get queued behind things that have nothing to do with your component, but you still need to go to the same code base. Service-oriented architecture was a concept. Actually, I don't know what the difference between service-oriented architecture and microservices is. I think microservices is just a standard de facto implementation of a service-oriented architecture. A service-oriented architecture expresses your application in certain abstractions and it says break it down into the smallest possible components that you can, with each component having a very unique value proposition that it's providing. And microservices is a way to implement that architecture.
Oh, okay. So let's just suppose if somebody is implementing this microservice architecture, how do they design it? How do they actually divide an application into different microservices?
Sure, beauty is in the eye of the beholder. So it really comes down to that. But yeah, once you, a tenet that you could follow when dividing things into smaller components is you break them down into the smallest possible components until breaking it down any further makes no sense. That's one way of thinking about it. Other people also break it down in terms of teams, on the front end team. So I'm just going to have a microservice just that deals with the front end or all of the activity in the front end. Then there's an API team, which is the backend team. So whatever the backend scalable infrastructure that you have to process everything that is coming from the front end, as well as the API layer and API management. And then there's the more stateful stuff at the back end of it, right? Stateful or even stateless transaction processing, as well as databases and so forth are sitting at the back end. So sometimes people divide them by teams, sometimes they divide them by functional areas. My preference is always to divide them by functional areas and start dividing them down as small as possible until you can't divide them any further.
Okay, but how about a situation where a certain part of the application will have a lot of transactions, a certain part of the application will not have that many transactions? So can that be sort of like a guiding principle?
Yeah, that is a good guiding principle, because the one that you would be testing or deploying with or monitoring with a lot of transactions per second is going to be very different from a few transactions, but they might actually be a very bulky transaction. You might be doing a big fetch from a database, right? So it's not heavy in terms of the input to the system, but what it's pulling is pretty big. So how you would test it, how would you deploy it, and what's the fault radius of that thing is pretty different. So that would be one way of thinking about it. But like I said, beauty is in the eye of the beholder. There is no easy rule. There is no standard best practice that I could define that covers all scenarios. So you have to really, as a development team, sit down and think about what gets you the best agility, what gets you the best safety, and the best performance.
So there are quite a few guys who say that, okay, designing microservices, you might end up in a situation it's like a noodle soup. There's so many services going around. So there must be quite a few challenges managing that or designing that. So how do you handle that?
All software is a noodle soup. So let's just start off with that principle, I think. So all software ends up being a noodle soup, or let me say it this way. All successful software ends up being a noodle soup. So yeah, you're going to have a noodle soup anyway. Now, do you have the right tools to drink and eat the noodle soup as and when required is what makes or breaks. I don't think whether your monolith versus a microservice is going to be a defining principle when it comes to whether software is a noodle soup. I think the only place where I see monoliths making sense are these sort of like run to completion, very, very high performance applications where you just need to start and do something. It's pretty simple, but it needs to go in like a certain flow and never deviate from it. So think of it, those kind of applications, yeah, like you should not even try doing a microservices architecture, but those are fewer and fewer.
What kind of challenges have you seen teams facing when working with these microservices?
So I've seen people struggle with defining proper APIs to communicate between microservices. So they start with a microservice architecture that becomes a monolith over time. That happens all the time, because you're thinking of, well, I've divided everything into subcomponents and there's some API, but then this one developer says, you know what, if I just pass this parameter directly, it'll be faster. You know what, if I just wrote it into this S3 bucket, can you just read from there? Yeah. And then all of a sudden that well-defined API boundary starts becoming what you were calling a noodle soup. And slowly what started off as a as a Power Ranger is a Ninja Turtle at the end of it, right? Like, so you basically have something that started off as very compartmentalized, very microservice architecture, because of lack of proper interfaces or lack of proper discipline to maintain those interfaces, end up becoming a monolith. Now you change one thing over here and everything starts breaking because there's like this bypasses to these APIs that you're using to communicate between services. So that's one common thing that I've seen, that you start off with the right intentions and that a good architecture, but over time it devolves into something completely different.
Okay, so there's the concept of obviously serverless, and it's pretty much attached with microservices. Is it one and the same thing or different?
No, serverless is different, but it's connected in certain ways. So serverless is a compute platform, right? Like serverless means that instead of having a VM or a container where you decide what operating system you want, what libraries, and all of those things, and you package them all together, and then you run your code on top of it. Most software do not require that. Most software just comes up, it needs to run, do something, either through an event or at a particular periodic interval, and then just do what it does and go away. Serverless is that concept that you can just throw functions at it or code at it without having to worry about packaging that code or learning about Linux and the intricacies of underlying operating systems or managing a big fleet of compute that runs your application. So serverless is that concept. So a microservice can have multiple serverless components, and it could have other components that are packaged as containers or VMs. So they're not mutually exclusive. Okay. What you would put inside of a serverless function, what business logic would you put inside of serverless needs to be more thought through, even inside of a microservice. So there should be things that are very generally stateless. They need to finish in a certain amount of time, and they don't have very high memory and those type of I/O requirements. So those are the kind of things that just you either run periodically, some small task, something simple, you just run it and does its task and goes away, either triggered through an event or through a periodic interval.
Okay, so let's just suppose when I say that I want to build microservices, I should use serverless or not?
You should use serverless until you can't use serverless. That's my philosophy.
Okay, can you please explain a bit?
So yeah, serverless is just easier. You don't want to deal with the intricacies of containers and build systems and fleet management, which just is just baggage that comes with containers and VMs, right? Or bare metal servers for that matter. So my philosophy is use serverless until you can't. Until you have an application that, because serverless does impose certain restrictions on the app, on what you could run inside of them, right? If you can't run inside of those functions, you really need something which is higher compute. You need to control the entire packaging of that system, and you need a fleet, then do it. But yeah, my philosophy is go serverless as much as you can.
Okay, so you're sort of like a proponent of serverless first strategy?
Yes.
So if you can explain more of serverless first?
Like I said, go serverless until you can't. So if it could be serverless, it should be serverless. So that's a very good strategy because it reduces the operational overhead of your team, of managing fleet, managing operating system version, patching. It just takes care of so much stuff that your team would inevitably have to deal with if they go with the non-serverless architecture. I also like another aspect of the serverless architecture, which is more behavioral and cultural, which is there are constraints on how much time it could run for. Let's say an AWS Lambda could run for 15 minutes. Mm-hmm. There's constraints on the storage that you could use. And those actually enforce really good behaviors, positive behaviors of the developers to keep their applications small, their function and business logic, break it down into smaller chunks. All of us say, my code should be small and CRs should be really small and it's easier to review, easier to test. But then you end up writing these functions that are like 5,000 lines of code, right? So the serverless architecture imposes these constraints that encourage best practices to be used by the developers as well. So that's just a byproduct of using serverless that I like.
So as a startup founder, if I'm building my MVP, so should I be aware of microservices? Should I be aware of all of the serverless, then build my MVP?
I think it's better done early. You could always, people do it all the time. They take a monolith and they break it down into smaller microservices. It's painful. If you start early, it's going to take you a little bit longer initially, but long term is going to have much more dividends. And what's the fundamental thing that differentiates one startup versus another, right? The two startups both are ride-hailing apps, right? Like if you don't have any fundamental differentiation, the differentiation is time. The agility to launch new things is what's going to differentiate.
That is where monoliths wouldn't win.
No, it won't, because your teams are now all tied to this one big monolithic code base, and the change in the front end is backed up behind this change in the database that have nothing to do with each other, right? So the teams can't independently deploy, test, write code. and everything is getting sort of like part of this big thing, and it needs to run this huge monolithic regression test suite over time. So the agility is very important, because in a startup, I'm like running 10% faster might mean you get 70% more market, right? I'm like, so putting a little bit of effort and time into the architecture upfront would have very high dividends in the long run.
So, but in terms of cost, if you are sort of like going via this microservice architecture, is it better than other forms?
Depends. I mean, like it depends on your application, because you could have a monolith that can be running in instances that are so big that you end up spending more cost that way. You might be running load balancers, which is configured in a way that it ends up being more costly. Or on the other hand, you could also not use serverless and use a lot of containers or VMs, and then your microservice could also be very costly. So it really depends on your use case, which one is more expensive or less expensive. Monoliths tend to be slightly less expensive.
Slightly less expensive. So in terms of CACD, so is monolith easier to manage?
No, it's horrible. It's horrible.
Okay.
It's like it's pain every day. So because think about it, it's a large code base. You change anything over here, something else will break that you never thought about breaking, right? And there's well-defined interfaces between microservices ensure that you're not exercising those kind of code paths, right? So it's CI/CD systems. I mean, like they just oil and water, right? Like, so this that's the only analogy I can do. So it's just harder to build, it's harder to deploy, it's harder to test. So microservices are much better in that sense.
All the way. So in terms of security, have you seen issues with this architecture?
With microservices or serverless?
With microservices.
I don't think there's like fundamentally anything different in the microservice architecture than you would see in other services, a monolith or microservice. You got to do your security reviews. The only thing that I can think of is that if you're not choosing serverless, then the responsibility of patching your host, maintaining your fleet, making sure no vulnerability exists is on you.
Okay.
That's why I said serverless until you can't.
Okay, so you're saying that for security reasons, serverless is the best way to go?
No, that's not what I'm saying. I'm just saying it takes away a big pain point.
Okay.
Which is fleet management is a huge pain when your fleet of VMs or servers becomes too big. It just takes away a huge pain point, operational pain point, security ops pain point from your team. Serverless is not easy to manage in terms of security as well, but it's not very hard either. I mean, it's not fundamentally different, but you gotta make sure that your serverless functions are as small as possible and they're just doing one thing and doing it well. And then you have fine-grained IAM policies that manage the communication between these different microservices, and you're putting them in different let's say you're using AWS, right? You're putting them in different accounts as well, and they're communicating not only just through inside of that account IAM policies, but also across account. You're creating those boundaries so that each team owns their space completely and has well-defined things through which they're communicating with each other.
Okay, so let's just dig a bit deeper into some of the challenges with the serverless architecture in terms of some of the runtime, resource isolations, and can you please elaborate more on that?
Sure, yeah. So there's a certain time budget. I like it because then it forces developers to think differently. But serverless can only run for a certain period of time and then they have to go away. So that's a good thing about them. Now you're building your application knowing that this thing's going to go away. It's not always going to be continuously running, right? So that's one thing you need to finish in a certain amount of time, and then it's just going to go away by the nature of how serverless is designed, right? So that could be a challenge as well. It could be a challenge because when you're making a decision, you can't finish, let's say in AWS and Lambda takes 15 minutes. So if you can't finish in 15 minutes, then you have to go to some other technology. That's easy. But what if it is taking you 5 minutes today, but under a high load situation, it takes you more than 15 times out? Okay. Now you've got to build the entire monitoring infrastructure. So those kind of things could be caught ahead of time. Mm-hmm. And you know that while you were okay and within the budget of that runtime constraint, when you designed that application, you've exceeded it. Okay. Either because your application or the user base has grown, or because under high load, you never really saw the 15-minute time window kick in until you have very high load. Mm-hmm. That's one aspect of it. Resource isolation is just another. Like the noisy neighbor problem exists irrespective of serverless or otherwise, right? In the cloud or even in your private or public cloud, you're running everything on the same infrastructure, so they are sharing resources with each other. In that sense, serverless is no different. But yeah, if you have a lot of serverless functions running on the same infrastructure, the noisy neighbor problem could be a little bit exacerbated, but it's not fundamentally different from how you would run your applications otherwise.
Okay, so let's just maybe dig a bit deeper into microservices and some of the issues related to security and latency. So is this a huge problem over there?
It used to be like there used to be a big it's microservices take longer movement. I think it's gone away. Compute has evolved so much over the past decade. I'm not seeing a big performance benefit of a monolith over microservices anymore. I'm sure there is if you're using IPC communication on the same Unix machine. It's faster than using an API. Let's say a GraphQL query across two microservices running on two different machines. But network fabrics, the switching architectures, as well as the compute architectures have evolved so much. It's not fundamentally different.
Okay.
Unless you're really in high performance computing and every nanosecond
I just suppose
counts.
there's a system where there's a lot of microservices and there's a lot of asynchronous calls coming in. Could there be a case of congestion and latency over there?
Yeah. No, but that doesn't change whether you're a monolith or a microservice, right? I mean, if you got a system with high TPS, you got to design a system to deal with high TPS.
Okay.
And one important consideration over here is to auto-scale your systems. Instead of building systems that are using a certain number of functions or certain number of VMs or containers, you auto-scale as your load grows. And almost every cloud, every technology that is out there allows you to auto-scale. So you're just really spending what you need for that transaction per second that you're seeing. For example, you're a food delivery service, right? I mean, your transactions per second are going to be much lower in the middle of the night than they are during lunch hour, right? So why are you paying the same amount if it's going to be the load is going to be so low during the night? So auto-scaling architecture is just sort of like scale in and scale out horizontally based on what the load is. And you should design your application that way, whether it's microservice or monolith. And microservice makes it easier because now you can really scale your application much more easily than you could with a monolith.
As a startup founder, what should be my motivation to start with this microservice architecture? And in terms of how will that impact my cost?
So my motivation as a startup founder would be agility, like I said, right? Can I move fast? Are my teams independent enough? That'll be one important advantage. Then safety and availability of my application is another one, right? Like that you're able to reduce the blast radius of your code. I mean, build test cases that are very specific to each microservice and not have unpredictable code paths. But there is also the advantage, if you're going serverless as much as possible, there's an advantage of cost over there as well, like you were alluding to. So in serverless, you just pay for what you are using, and you don't need to keep running that VM or that container for a long period of time if you don't really need to run it for a long period of time. It just comes, does its thing, goes away.
Okay.
And you're just paying for while it's active. So that is actually a huge cost benefit, and it can drastically reduce your cost of infrastructure by just running it that way. So that's just an added benefit of using more serverless in your architecture, and goes back to my favorite quote of go serverless until you can't.
Okay, but these costs versus on-prem solution, which one would be better?
On-prem also has serverless, like even VMware supports serverless at this point. So I think it doesn't really matter because the cost is how long are you using that infrastructure, and are you hogging resources when you don't need to, right? Whether it's on-prem or on the cloud is the same thing. Of course, on the cloud it's going to cost you more long running, but yeah, the idea is the same. Are you hogging a resource that you don't need to? And serverless takes you away from that, right? You just use it while you need it, and then you just release that resource that somebody else can actually use it. So you just get more out of the same infrastructure that you've deployed in the private cloud or in the public cloud.
So what different types of APIs microservices can use to communicate with one another? What different types are there?
Yeah, so there are many types, but yeah, I think the four standard types is one of them is your YAML or JSON, which is used Like, don't hate me for it, but yeah, S3 JSONs are still a pretty common way for microservices to communicate with each other. There's nothing wrong with it, as long as that schema is well defined and it's agreed upon and it's not changed willy-nilly. I think it's a pretty standard and good interface for microservices to communicate with each other, which is an actual storage system providing a JSON or a YAML interface through which they communicate with each other. If you need more real-time interaction, then REST has always been around, and you can have an HTTP-based interface using REST. The problem with REST is that if you make a call, you always get the same blob of information back. So you don't really get, first of all, the clients get a big blob of information and it keeps getting bigger and bigger over time. And the second thing is on the server side, you don't really know which part of this big blob of information are they really interested in. So that problem is solved by GraphQL interfaces where you really return what they're really looking for. What is that one piece of information in this big blob of API backend that you have available that the client was really interested in, and that could help you build better business metrics that reduces the I/O as well as communication and performance penalties that you take just by sending big blobs of information back and forth. So that's another real-time interface which is much more fine granular. Slightly harder to implement, but I think it's an investment worth making when you're building these interfaces and if you think your REST API is going to grow over time. And the last one is WebSockets, where you can actually have WebSockets that can, which is more of a pub sub interface. You're publishing and subscribing to information. That's just super real time. Something comes up, it can get published on a WebSocket.
So Ali, what is the best way to implement these APIs?
I think there's a lot of libraries that are already available to implement this API. My meta feedback would be don't try to implement it yourself, just use something standard. If you're going on the public cloud, even technologies like, for example, AWS has API Gateway and other clouds have similar technologies. They're very easy to spin up, very easy to set up, and they can provide a RESTful interface in no time that can do CRUD operations on your backend infrastructure. So just go with something like that, something more standard, something that has a developer community behind it, instead of cooking up your own.
Okay. So explain the way to implement service discovery in microservice architecture.
Yeah, this used to be a thing. Like back in the day, so there were so many different service discovery architectures, and there's a lot of debate around this as well. But now everybody just uses DNS, and I love it. It's so simple. Every service has a name. You register it with a DNS. It could be a local DNS entity running in your own environment. And that just tells you how to communicate with that, where that service is located. So the registration, the service registration and the service discovery is really standardized around DNS, which I really love, because there used to be some very complex architectures that were in place earlier that have just gone obsolete over time. So if you know your DNS, you're fine. Okay.
So in terms of evolution, in terms of where all of this architecture debates will go to, what are your opinions?
I think the winner has been called in certain ways on the microservice architecture. Similarly, on the serverless, I think the winners have been called. It's not a debate anymore. So in terms of the future of compute, I think you'd see more and more serverless. But there are just workloads that cannot be serverless. They need beefy VMs. They need containers. And I think that's what you're going to have to pick and choose for each workload, each use case separately as to what part of it goes into serverless. You generally cannot build an entire microservice. You probably could, but not with one serverless function, right? It's just a bunch of serverless function, or a mix of serverless and container, or a mix of serverless and container, and databases running as VMs. So I think this is the evolution of where compute is going. That the smallest form factor first. If it cannot fit into that, go to the second one, and then go to the biggest one as the last resort if you can't fit it into the first two.
Okay, Ali. Thanks a lot for your time.
Thank you for having me.
Really appreciate it.